Okay. Oh, this is one of my favorite ones from this. Kevin writes a sequence of numbers starting with 1 and repeatedly adding 1 until a multiple of 2 is reached. He then repeatedly adds 2 to this value until a multiple of 3 is reached, then adds 3 until he gets to a multiple of 4, and so on. The first 4 terms are 1, 2, 4, and 6. What will be the last term Kevin writes down before he adds 2,000 for the first time? And so with sequences problems, just write out 10 terms first. And usually humans are very good at spotting patterns, and you'll just spot a pattern and that will help you solve it. Okay, so 1, 2, and then so we've reached a multiple of 2, and now we add 2 until we hit a multiple of 3. Now we add a multiple of 3 until we hit a multiple of 4. Add multiples of 4 until we hit a multiple of 5. Add 5 until we hit a multiple of 6. And it's like the first thing to notice is that, whoa, we add 2 numbers each time before we hit the next thing. And so this is a very regular pattern. And so let's just write down like n and last term written before adding n for the first time, because the final thing we want to find is the last term that Kevin writes down before he adds 2,000 for the first time. So the last number he writes down before adding 2 for the first time is 2. The last number he writes down before adding 3 for the first time is 6. For 4, it's 12. For 5, it's 20. For 6, it's 30. And there's a pattern here. It's n goes to n times n minus 1. Decently clear with the pattern. You can prove this. The sequence will end up being like n. It'll go from like n to n minus 1, and then you add n and it goes to n squared, and then you add n again and it goes to n times n plus 1, and you hit your multiple of n plus 1. And then you add n plus 1, and you get n plus 1 squared. And so this is the generally what the sequence looks like. But we can just find out here what the last value we plug in n equals 2,000. So 2,000 goes to 2,000 times 1999, which is 3,998,000. And that is problem 26. That is I think that's a nice one. It has like, I like this kind of problem. It's called rigid. That's what like the philosophy of this is called.